question number 54. Whenever I start these large circle problems, I try to fill in anything that they give me. AB is a tangent. This word might not actually be helpful, but as soon as you write tangent, you really can put in your right angles because tangents make right angles at their point of tangency, in this case, point A. Second piece of information, AD is equal to 90 degrees. DH, which is this entire section, that orange section is equal to 40. And this smaller section, GH, this little part, is equal to 30. Meaning DG, might as well just write this down, is equal to 10. Okay, the first thing that I notice is there's a few kind of obvious things I should fill in. For example, I see that AD is 90. I might as well fill in that the central angle will then be 90. If angle 3 is 90, so is angle 9. I guess those are the really obvious ones. I could come down to number 8 as well. Because 8 is an inscribed angle from DH, it won't be equal to 40. It'll actually be equal to 20, or half of 40. Okay, let's start filling in what we know. The measure of angle 1 is already marked on your picture. It's a 90-degree angle, and that's because it's the angle is formed by the tangent. Angle 2, when I first looked at it, I wanted to write 45 degrees, but it's not. Angle 2, the intercepted arc, is bigger than you think because it goes all the way down to here. So angle 2 actually intercepts this whole section. So that's not just a 90, that's a 10 as well. So angle 2 is not equal to 100, it's equal to half of 100. So angle 2 is equal to 100 divided by 2. Angle 2 is equal to 50 degrees. So that's a 50. That's a 90. Next, angle 3. Angle 3 we've already mentioned it's 90 degrees because it's central to the 90-degree arc that was given in the problem. Angle 4, I'm going to have to use a little bit of the sum of interior angles of a triangle. I know that this one's 90. If I look at angle 2 and 10, 10 has to be 40 because I know together angle 2 and 10 have to be complementary or equal to 90. I'll go ahead and fill that in now, and then I'll go back and tell you what that means to me. I now have a 40, I have a 90. That makes 130 altogether. That means angle 4 has to be 50 degrees. And again, that's because this whole triangle here has a sum of 180. And if I already know 2, then I can just subtract to get the last. Looking for angle 5. Angle 5, if you notice, intercepts two different arcs. One of the arcs it intercepts is the 90, and the other arc it intercepts is the 30. Because it's not as big as 90 and as small as 30, I'm actually going to average them. Angle 5 is equal to the average of 90 and 30, which is 120 divided by 2, 60 degrees. We're now down to angle 6. Oh, I know 6. 6 intercepts the diameter. Whenever you have an angle that is an inscribed angle to the diameter, it's essentially a semicircle. 6 is going to be equal to 90 degrees. Let's see, 7. 7 is going to be 7 is on the outside, and it intercepts two arcs. It intercepts a 30 here, and all the way over here, it intercepts a 90. Now, because the vertex is on the outside, I'm going to find the difference between those two before I divide by 2. So angle 7 is going to be equal to 90 minus 30 divided by 2, which is just 30 degrees. Measure of angle 8. Oh, good, I already knew that one. That's 20. The measure of angle 9, I already know that one. That's 90. And measure of angle 10, I'm done.